Hello, we are going to present about the formation of our solar system. Hope you enjoy. During the first 3 minutes of the universe, temperatures cooled, and protons and neutrons collided to make an isotope of hydrogen. Let me explain a little bit more. What does this mean? Nucleosynthesis is the creation of new atomic nuclei that are the centers of the atoms that are made up of protons and neutrons. Nucleosynthesis first occurred within a few minutes after the Big Bang. At that time, a quark gluon plasma, a soup of particles known as quarks and gluons, condensed into protons and neutrons. Further reactions between protons and neutrons and different isotopes of helium produced lithium. The hydrogen and helium produced during this phase of the universe eventually created the universe's first massive stars. In the past, these processes also produced the elements on the periodic table that we know today. As the universe cooled, conditions became just right to give rise to the building blocks of matter. The first galaxies may have formed much earlier than we thought. A new study suggests just 200 million years or so after the universe's birth.
Galaxy formation. The first galaxies took shape 1 billion years after the Big Bang, so this probably took place 13 to 14 billion years ago. There are two leading theories to explain how the first galaxies formed. So the first one says that they were born after vast clouds with gas and dust collapsed under their own gravitational pull, allowing stars to form. And the other one, they say is more credible in these recent years, is that the young universe contained many small lumps of matter that they clumped together to form galaxies. So to this theory, most of the early large galaxies were spirals. Many spirals merged to form ellipticals over time. But the galaxy formation has never stopped and our universe continues to evolve. So there are small galaxies are frequently glow up by larger ones, like the Milky Way. The Milky Way contains the remains of several smaller galaxies that it has swallowed during its long lifetime.
Birth of the Sun. The Sun is 4.5 billion year old yellow dwarf star, a hot glowing ball of hydrogen and helium at the center of our solar system. It is about 93 million miles from Earth, and it is our solar system only star. Without the sun energy, life, as we know it, could not exist on our home planet. Our Sun is one of at least 100 billion stars in the Milky Way, a spiral galaxy about 100,000 light years across. The stars are arranged in a pinwheel pattern with four major arms, and we live in one of them, about two-thirds of the way outward from the center.
Around 4.5 billion years ago, our solar system began as a vast cloud of gas and dust known as a solar nebula. This nebula contained elements and compounds left over from previous generations of stars that had gone through their life cycles and exploded in supernova. These materials included hydrogen and helium, as well as heavier items like carbon, oxygen, silicon, and iron. The collapse of the solar nebula. Some events, possibly the shock wave from a nearby supernova or a passing star, triggered the collapse of the solar nebula. This collapse initiated the process of star and planet formation. Now, for the formation of the protostar, as the nebula collapsed, it began to spin, forming a spinning disk of material. At the center of this disk, a dense concentration of gas and dust formed what would become the Sun, our central star. This early phase of the Sun's life is called a protostar. Now, let's talk about the formation of the planets. These planets, including Earth, formed within the rotating disk of the solar nebula through a process known as accretion. Here's how it happened. Dust grains and ice. Within the disk, tiny dust grains and ice particles stuck together through mutual gravitational attraction, forming larger and larger clumps. Planetesimals. These clumps, called planetesimals, continued to collide and accumulate material. Some planetesimals grew to several kilometers in size. Protoplanets. Over time, some planetesimals became massive enough to be called protoplanets. These protoplanets were the building blocks of the planets. And finally, clearing of orbits. As protoplanets grew, they cleared out their orbits of smaller debris and gas. This is when the planets began to take on their current shapes and sizes. Moving on to the formation of Earth. Earth, like the other terrestrial planets like Mercury, Venus, and Mars, formed from the dust and planetesimals within the inner part of the solar nebula. Here's a closer look at the Earth's formation. Accretion. Over millions of years, Earth's core formed through the accretion of heavy elements such as iron and nickel. Differentiation. As Earth grew, it began to differentiate, with denser materials sinking towards the center to form the core, while lighter materials rose to form the mantle and eventually the crust. Finally, atmosphere and oceans. As Earth continued to accrete, it captured gases from the surrounding nebula, forming its atmosphere. Water vapor condensed to create the oceans. Finally, talking about the formation of the moon's formation is thought to be the result of giant impact hypothesis. First, we have impact. A Mars-sized object, often referred to as Theia, collided with the young Earth around 4.5 billion years ago. Debris talks about the impact that was so violent that it caused a massive amount of debris to be injected into space, and later on, this debris began to orbit Earth. Finally, we have moon formation. Over time, the debris from the collision merged and formed the moon. The moon's composition is similar to Earth's mantle.
Thank you for your attention.